Before we begin our data structures and algorithm journey, let's talk about analysis of algorithms. Analysis of algorithms is super important before we start writing algorithms or before we start learning data structures. Why is it important? For a given problem, there can be multiple solutions, and these multiple solutions might be using different algorithm techniques, might be using different data structures. How do you decide as a programmer which one is better? And this is where analysis of algorithm plays an important role. So we are going to discuss this problem where we are given a number n and our task is to find sum of first n natural numbers. Right? For example, if n is 3, then our output is going to be 6. How do we get 6? 1 plus 2 plus 3. We need to find sum of first n natural numbers. If n is 5, then our output is going to be 15. 1 plus 2 plus 3 plus 4 plus 5. See, in this video, I have written complete input and output. In the upcoming videos, to save writing too much text on the board, I am going to use IP for input and OP for output, right? Just to save the space here. So we have an input number n. We need to write a function that returns sum of first and natural numbers. Please pause this video and try to write down a function yourself. We are going to discuss 3 different solutions of this problem, and then we are going to compare these 3 different solutions. Here are 3 different solutions written by 3 different programmers, and your solution very likely might be matching one of these 3 solutions. The first programmer has simply returned n into n plus 1 by 2. It simply uses the formula, right? If n is 3, we are going to return 3 into 4 by 2, which means 6, right? The second programmer implemented the loop logic. What this programmer did, initialize the sum as 0, then 1 by 1 added all the natural numbers. First added I equal to 1, then 2, then 3. So this is how you get sum of 3 natural numbers. If n is 4, then the programmer is going to run the loop for till 4 and it's going to add 1, 2, 3, 4, right? So this is how the idea of second programmer is. The third programmer, what it did, it used nested loops, one loop inside the other. And what happens here, the programmer runs a loop from 1 to n, right? And then runs a loop from j equal to 1 to I. And for every iteration of the inner loop, it does sum plus plus. So what it is doing, it is having sum as 0. Then for the one iteration of the outer loop, the inner loop will run once only, right? So it will add 1 to the sum, right? So sum will be getting 1 added. Then when the next iteration of the outer loop comes, the outer loop runs for I equal to 2. And for I equal to 2, the inner loop runs 2 times for j equal to 1 and j equal to 2. So sum gets added 2 times. And in the third iteration, 1 is added 3 times, right? We do sum plus plus means we add 1 to sum. Right? So this is how we get again sum equal to 1 plus 2 plus 3 and we get the result as 6. So this programmer is actually adding 1 n into n plus 1 by 2 times to sum, and this is how this programmer is getting the sum. So these 3 functions give you the correct output. Now the question arises, which of these 3 functions is going to take the least time? Which of these is most efficient? See, when you talk about time taken by a program, it depends upon many factors. It depends upon the computer on which you are running. Suppose you write an inefficient program to solve, say, this natural number sum problem, and you run it on a very fast machine. Then your inefficient program might take less time compared to the other efficient program that you've written and run on a slow machine, right? The one factor is machine, processing power of the machine. The other factor is programming language. See, programming languages like C and C++ are compiled languages, and Java and Python are interpreted. So what happens in C and C++, when you generate the binary, it's specific to your machine and the binary runs on your machine. It's native to your machine. But when you write Java and Python codes, the code that is typically generated is intermediate code and it's interpreted. It's run line by the interpreter. That's why the Java and Python programs typically run slower. So it depends upon the programming language also. If you have written in C and C++, it's likely to take less time compared to Java and Python. Even if you write these 3 functions in same programming language and you run on the same system, you might not be exactly able to figure out which one is more efficient due to reasons like system load. Say when you were running an efficient code, right, the most efficient of these three, at that moment what happened was your system was running a background upgrade. It was loaded. So what might happen is your system might take more time for an efficient solution. Now comes one more very important problem. Say you and your friend, you both wrote different solutions to solve a problem. For certain inputs, say your friend's solution is more efficient, and certain other inputs, your solution is more efficient. Now, how do you figure out which one is more efficient? Because for certain inputs, his solution is taking less time, and for certain inputs, your solution is taking less time. To overcome all these problems, all the problems that I've discussed so far, we have a solution called asymptotic analysis, which is a theoretical and mathematical analysis. With asymptotic analysis, we don't even have to implement all the solutions. By looking at the algorithms, by looking at the solutions, we can tell which one is more efficient theoretically.